students, I wish to draw your attention to the next question. Now the question number 41 has appeared on your screen. Solubility product of MgOH twice is 1 into 10 to the power of minus 11. At what pH will MgOH twice start precipitating from a solution of 0.001 Mg2 plus? ಹಾಗಂದ್ರೆ ಏನು ಅಂತ ಹೇಳಿ. ಈಗ ನೋಡಿ, ನಮ್ಮ ಹತ್ರ ಒಂದು Mg2 ಪ್ಲಸ್ ಸೊಲ್ಯೂಷನ್ ಇದೆ. ಹಾಗಾದ್ರೆ ಏನರ್ಥ? ನಮ್ಮ ಹತ್ರ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಯಾವುದೋ ಒಂದು ಮೆಗ್ನೀಷಿಯಂ ಸಾಲ್ಟ್ ನ ಕರಗಿಸಿದೀವಿ. ಯಾವ ಮೆಗ್ನೀಷಿಯಂ ಸಾಲ್ಟ್ ಕರಗಿಸಿದ್ರು Mg2 ಪ್ಲಸ್ ಇರುತ್ತೆ. ಆಯ್ತಾ? ನಾವು Mg2 ಪ್ಲಸ್ ನ ಪ್ರೆಸಿಪಿಟೇಟ್ ಮಾಡಬೇಕು. MgOH twice. Precipitate ಅಂದ್ರೆ that is insoluble in water. We want to convert Mg2 plus to MgOH twice precipitate. MgOH twice ಗೆ KSP solubility product ಕೊಟ್ಟಿದ್ದಾರೆ. Solubility product ಅಂದ್ರೆ MgOH twice slightly ionizes to give Mg2 plus 2OH minus. Solubility product ಬರಿಬೇಕಾದ್ರೆ ionization equation first ಬರ್ಕೊಳ್ಳೇಬೇಕು. KSP equals product ಅಲ್ಲಿರೋ ion concentration ನ multiply ಮಾಡಿ. Concentration of Mg2 plus into concentration of OH minus plus square. Stoichiometric coefficient ನ ಪವರ್ ಅಲ್ಲಿ ಬರಿಬೇಕು. Solubility product ಬರಿಬೇಕಾದ್ರೆ ionization equation ಬರ್ಕೊಂಡು KSP ಬರಿಬೇಕು. ಆಯ್ತಾ? ಈಗ KSP ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ. ಎಷ್ಟಪ್ಪ? 1 into 10 to the power of minus 11. Mg2 plus ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡು, 0.001 ಅಂದ್ರೆ 10 to the power of minus 3. OH minus ಕಂಡುಹಿಡ್ಕೋಬಹುದು. 10 to the power of minus 3, 10 to the power of minus 11. ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದ್ರೆ 10 to the power of minus 8 ಬರುತ್ತೆ. OH minus the whole square. Square root ತಗೊಳ್ಳಿ. OH minus equals 10 to the power of minus 4 molar. ಆಯ್ತಾ? OH minus 10 to the power of minus 4 ಇದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ POH ಬರೀಬಹುದು 4. 10 to the OH minus concentration ಗೊತ್ತಿದ್ರೆ POH ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀಬಹುದು. pH equals ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು pH plus POH equals 14. So POH 4 ಇದ್ರೆ pH ಎಷ್ಟಾಗಬೇಕು? 10. pH 10 ಇದ್ದಾಗ precipitation start ಆಗುತ್ತೆ. When the ionic product is equal to solubility product, precipitation starts taking place. ಆವಾಗ OH minus ಕಂಡುಹಿಡ್ಕೊಂಡು OH minus ಇಂದ POH ಗೊತ್ತಾಯ್ತು. POH ಕೇಳಿಲ್ಲ ನಮಗೆ, pH ಕೇಳಿದ್ದಾರೆ. pH will be 10 because pH plus POH equals 14. ಇನ್ನೊಂದ್ಸಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನೋಡಿ. ಸಾಲ್ಯುಬಿಲಿಟಿ ಯಾವಾಗ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ when the ionic product is equal to solubility product, then the precipitation just begins. KSP ಕೊಟ್ಟಿದ್ದಾರೆ, Mg2 plus ಕೊಟ್ಟಿದ್ದಾರೆ, ಅಂದ್ರೆ OH minus ನ ಕಂಡುಹಿಡಿಯಬಹುದು. OH minus ಕಂಡುಹಿಡಿದ್ರೆ POH ಗೊತ್ತಾಗುತ್ತೆ. POH ಗೊತ್ತಾದ್ರೆ pH. Yes. Question number 42. pH of a saturated solution of BaOH twice is 12.0. What is its KSP? This problem is the converse of the previous problem. if you mind, you can do it. If you have understood the previous problem properly, definitely you can answer this question on your own. Anyhow, I will answer it. pH of a saturated solution of BaOH twice. ನೋಡಿ KSP ಬರಿಬೇಕಾದ್ರೆ again I will recall ionization equation first ಬರಿಬೇಕು. Ba2 plus 2 OH minus. KSP ಬರೀರಿ. KSP equals square bracket Ba2 plus into square bracket OH minus the whole square. ಈಗ ನಮಗೆ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ Ba2 plus ಕೊಟ್ಟಿಲ್ಲ, ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ OH minus ಕೊಟ್ಟಿಲ್ಲ. ಎರಡು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಫಸ್ಟ್ OH minus ಮಾಡ್ಕೊಳ್ಳೋಣ. ನೋಡಪ್ಪ, pH ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? 12. pH 12 ಆದ್ರೆ pOH ಎಷ್ಟು ಆಗಬೇಕಾದ್ರೆ pOH should be 2. pOH 2 ಆದ್ರೆ OH minus should be 10 to the power of minus 2 molar. ಒಂದಾಗುತ್ತೆ. OH minus ಕಂಡುಹಿಡಿಯಬೇಕು. Ba2 plus ನೋಡು, OH minus ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಮ್ಮ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ 10 to the power of minus 2 molar. ಈಗ ಈಕ್ವೇಶನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸ್ಟಾಕಿಯೋಮೆಟ್ರಿ. ನಮ್ಮ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ 2OH minus ಬಂದ್ರೆ Ba2 plus ಒಂದೇ ಬರೋದು. ಅಂದ್ರೆ ಅರ್ಥ ಎಷ್ಟು OH minus ಬರುತ್ತೋ ಅದ್ರಲ್ಲಿ ಅರ್ಧ ಮಾತ್ರ ಬರುತ್ತೆ Ba2 plus. ನಮ್ಮ ಈಕ್ವೇಶನ್ ಇಂದ ಗೊತ್ತಾಗುತ್ತೆ ಎಷ್ಟು ಬಂದಿದೆ, 10 to the power of minus 2. ಹಾಗಾದ್ರೆ ಅರ್ಧ ಅಂದ್ರೆ half into 10 to the power of minus 2 ಬರುತ್ತೆ Ba2 plus. half into 10 to the power of minus 2 ಅಂದ್ರೆ 0.5 into 10 to the power of minus 2 ಅಂದ್ರೆ 5 into 10 to the power of minus 3. ಹಾಗಾದ್ರೆ ನಮ್ಮ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ Ba ಜಾಗಕ್ಕೆ 5 into 10 to the power of minus 3, OH ಜಾಗಕ್ಕೆ 10 to the power of minus 2 the whole square. ಇವಿಷ್ಟು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ 5 into 10 to the power of minus 3 into 10 to the power of minus 4 ಅಂದ್ರೆ 5 into 10 to the power of minus 7. That is the answer. That is the solubility product. ಇನ್ನು ಒಂದ್ಸತಿ ವರ್ಕ್ ಮಾಡಬೇಕು ನೀವು. pH ಕೊಟ್ಟಿದ್ದೆ ನಾನು 12, pOH2 ಅಂತ ಹೇಳಿದ್ರೆ OH minus is 10 to the power of minus 2 molar. OH minus ಗೊತ್ತಾಗೋಯ್ತು. Ba2 plus ಅವ್ರು ಕೊಟ್ಟಿಲ್ಲ, ನಾವೇ ಮಾಡ್ಕೋಬೇಕು. ಅದಕ್ಕೆ ನಮ್ಮ ಅಯೋನೈಸ್ ಈಕ್ವೇಶನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ನಮ್ಮ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ಗೊತ್ತಾಗ್ತಾ ಇದೆ ಎಷ್ಟು OH minus ಬರುತ್ತೋ ಅದ್ರಲ್ಲಿ ಅರ್ಧ ಬರುತ್ತೆ Ba2 plus. 10 to the power of minus 2 ಬಂದ್ರೆ half into 10 to the power of minus 2 ಅಂತ ಬರುತ್ತೆ. half into 10 to the power of minus 2 ಅಂದ್ರೆ 5 into 10 to the power of minus 3. Once we know Ba2 plus and OH minus, you can calculate. It is 5 into 10 to the power of minus 7. That was question number 42. Question number 43. I think this is an easy question. Question number 43 is an easy question. Which of the following is a buffer? Buffer andre a solution which maintains constant pH even after adding a little acid or base. ಗೊತ್ತಿಲ್ಲದೆ ಇದ್ರೆ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಬಫರ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕಾದ್ರೆ weak acid plus its salt ಅಥವಾ weak base and its salt ಬೇಕಾಗುತ್ತೆ. ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಇಂದ ಬಫರ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಬಫರ್ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕಾದ್ರೆ ಯು ನೀಡ್ ಎ ವೀಕ್ ಆಸಿಡ್ ಅಂಡ್ ಇಟ್ಸ್ ಸಾಲ್ಟ್ ಆರ್ ಎ ವೀಕ್ ಬೇಸ್ ಅಂಡ್ ಇಟ್ಸ್ ಸಾಲ್ಟ್. ವಿಚ್ ಆಫ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಇಸ್ ಎ ಬಫರ್? ಮೊದಲನೇದನ್ನ ಬಿಟ್ಬಿಡಿ. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಯಾಕೆ? NaOH is a strong base. You can't prepare a buffer using a strong base. ಎರಡನೇ ಆಪ್ಷನ್ ಬಿಟ್ಬಿಡಿ. HNO3 is a strong acid. HNO3, HCl, H2SO4. These three are strong acids. C. Third option ಬಿಟ್ಬಿಡಿ. HCl is a strong acid. Obviously, the fourth option should be correct. HNO2 is a weak acid. NaNO2 is its salt. ಅದರದ್ದೇ ಸಾಲ್ಟ್ ನೋಡಿ, H ಜಾಗಕ್ಕೆ NaNO2 is a weak acid and its salt. Therefore, this is a buffer. ಇನ್ನೊಂದ್ಸತಿ ಹೇಳ್ತೀನಿ, a weak acid plus salt or a weak base and its salt is a buffer. You can't prefer a buffer using a strong acid or strong base. Ishtu gottidre idu an easy question you can answer. Question number 44 has appeared on the screen. ನಿಧಾನವಾಗಿ ಓದ್ಕೊಡಿ. pKa of a weak acid is 4.5. pKa of a weak acid is 4.5. pOH ಕಂಡುಹಿಡಿಯಬೇಕು. Given the weak acid HA is 50% ionized. ಅರ್ಥ ಆಯ್ತಾ? ಅಲ್ಲಿ 4 ಆಪ್ಷನ್ಸ್ ಇದೆ. Remember, it is an acidic buffer. ಅರ್ಥ ಆಯ್ತಾ? ಅಸಿಡಿಕ್ ಬಫರ್ಗೆ POH ಕೇಳಿದ್ರು, ಅದನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. POH. ಸೊ ಬಫರ್ HA ಅಂತ ಕೊಟ್ರೆ ಇಟ್ ಇಸ್ ಎ ವೀಕ್ ಆಸಿಡ್. ವೀಕ್ ಆಸಿಡ್ ಅಂತ ಈ ಜಾಗದಲ್ಲಿ ಹೋಗುತ್ತೆ. A ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದ ವೀಕ್ ಆಸಿಡ್. ಅದು ಒಂದು ಈಕ್ವೇಶನ್ ಇದೆ, ಅದಕ್ಕೆ ಹೆಂಡರ್ಸನ್ಸ್ ಈಕ್ವೇಶನ್ ಅಂತ ಕರೀತಾರೆ. ಇದು ಗೊತ್ತಿದ್ರೆ ಮಾತ್ರ ಈ ಪ್ರಾಬ್ಲಮ್ ಮಾಡೋದಕ್ಕೆ ಸಾಧ್ಯ. pH equals pKa plus log of salt concentration over acid concentration. ಇದು acidic buffer. pOH equals pKb plus log of salt over base. ಇದು ಬೇಸಿಕ್ ಬಫರ್ಗೆ. ಇವೆರಡು ಈಕ್ವೇಶನ್ಸ್ ಸೇರಿ ನಾವು ಹೆಂಡರ್ಸನ್ಸ್ ಈಕ್ವೇಶನ್ ಅಂತ ಕರೀತೀವಿ. ಈಕ್ವೇಶನ್ ಗೊತ್ತಿದ್ರೆ ಮಾತ್ರ ಈ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಇದು ಅಸಿಡಿಕ್ ಬಫರ್. ಇಲ್ಲಿ A ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದಾನು ಗೊತ್ತಾಗುತ್ತೆ, HA ಅಂತ ಕೊಟ್ಟಿರೋದ್ರಿಂದಾನು ಗೊತ್ತಾಗುತ್ತೆ ಇದು ಅಸಿಡಿಕ್ ಬಫರ್ ಅಂತ. ಈ ಈಕ್ವೇಶನ್ ಉಪಯೋಗಿಸಬೇಕು. ನೋಡಿ, ಈಕ್ವೇಶನ್ ಉಪಯೋಗಿಸೋಕ್ಕಿಂತ ಮುಂಚೆ ಅಯೋನೈಸೇಷನ್ ಬರ್ಕೋಬೇಕು. ಆಯ್ತಾ? ಈ A ಮೈನಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಾವು ಸಾಲ್ಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ಕರೀತೀವಿ. ಆಯ್ತಾ? ಲುಕ್ ಹಿಯರ್. ಸಪೋಸ್ ಇಲ್ಲಿ ಇದು 50% ಅಯೋನೈಸ್ಡ್ ಅಂದ್ರೆ ಇದು 1 ಮೋಲ್ ತಗೊಂಡ್ರೆ ಇದರಲ್ಲಿ ಅರ್ಧ ಮಾತ್ರ ಅಯೋನೈಸ್ ಆಗಿರುತ್ತೆ. ಒಂದರಲ್ಲಿ ಅರ್ಧ ಅಂದ್ರೆ ಎಷ್ಟಪ್ಪ? 0.5. 0.5 ಅಯೋನೈಸ್, ಒಂದು ಅಯೋನೈಸ್ ಆದರೆ ಇದೊಂದು ಬರುತ್ತೆ. 0.5 ಅಯೋನೈಸ್ ಆದರೆ 0.5 H ಪ್ಲಸ್ 0.5 A ಮೈನಸ್ ಬರುತ್ತೆ. ಆದ್ದರಿಂದ H ಪ್ಲಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ 0.5, A ಮೈನಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇಸ್ 0.5. ನಮ್ಗೆ ಅದೇ ಬೇಕಾಗಿರೋದು. ಅನ್ಅಯೋನೈಸ್ ತಗೊಂಡಿದ್ದು ಒಂದು 0.5 ಅಯೋನೈಸ್ ಆಯಿತು. ಅನ್ಅಯೋನೈಸ್ಡ್ ಆಸಿಡ್ ಎಷ್ಟು? 0.5. ಇಲ್ಲಿ ಸಾಲ್ಟ್ ಓವರ್ ಆಸಿಡ್ ಅಂತ ಇದೆಯಲ್ಲ, ಈ ಜಾಗದಲ್ಲಿ ಅನ್ಅಯೋನೈಸ್ಡ್ ಆಸಿಡ್ ಬರೀಬೇಕು. ಈ ಜಾಗದಲ್ಲಿ A ಮೈನಸ್ ಬರೀಬೇಕು. ಇಲ್ಲಿ A ಮೈನಸ್ ಬರೀಬೇಕು. ಈ ಜಾಗದಲ್ಲಿ HA ಬರೀಬೇಕು. ಈಗ ನೋಡಿ, pH equals pKa ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ 4.5 plus log of salt concentration is 0.5, acid concentration is also 0.5. Therefore, it becomes log of 1. Log of 1 is 0. Therefore, pH equals 4.5. ಆದರೆ pH ಎಲ್ಲ ಕೇಳಿರೋದು POH. ಅದೇನು ಬಹಳ ಸುಲಭ. pH 4.5 ಆದರೆ POH is given by 14 minus pH, and the 14 minus 4.5 and the 9.5. That is the answer. So option D. Equation la correct barkobeku. Question 45 has appeared on the screen. This is also fairly easy question. Which of the following is both a Bronsted acid and Bronsted base? 4 options ಇದೆ. ಜ್ಞಾಪಿಸ್ಕೊಳ್ಳಿ, Bronsted acid ಅಂದ್ರೇನು, Bronsted base ಅಂದ್ರೇನು ಅಂತ ಜ್ಞಾಪಿಸ್ಕೊಂಡು you just to try to answer this question. Bronsted acid ಅಂದ್ರೆ ನೋಡಿ, that which donates H plus is Bronsted acid. That which accepts H plus is Bronsted base. It is Bronsted acid, it is Bronsted base. Suppose if one of the 4 substances can function as both proton donor as well as proton acceptor. ಅದಕ್ಕೆ yes, you have to find out the one which can do both of this. Yes. ಈಗ ಸೋಡಿಯಂ ಕಾರ್ಬೋನೇಟ್ ಅಲ್ಲಿ ಕಾರ್ಬೋನೇಟ್ ಅಯಾನ್ ಇದೆ. ಆ ಕಾರ್ಬೋನೇಟ್ ಅಯಾನ್ ನೋಡ್ತಿದ್ದ ಹಾಗೆ ಹೇಳ್ಬೋದು, it can never be a proton donor because it has no proton. ಜೋಬಲ್ ಕಾಸಿದ್ರೆ it can be called a donor. ಖಾಲಿ ಜೋಬಲ್ ಇರೋನ್ನ ಡೋನರ್ ಅಂತ ಕರೆಯಕ್ಕೆ ಆಗೋದಿಲ್ಲವಾ? ಹಾಗೆ ಕಾರ್ಬೋನೇಟ್ ಅಯಾನ್ has no proton. It cannot be a proton donor. It can be a proton acceptor. It can definitely accept a proton to become HCO3 minus. Therefore, it can be a Bronsted base only and not Bronsted acid. OH minus. ನಿಮಗೆ ಗೊತ್ತಿದೆ, OH minus readily accepts H plus to give H2O. OH minus very difficult to take out a proton from H plus, OH minus. Therefore, this is also a Bronsted base. ಈಗ HCO3 minus ತಗೊಳ್ಳೋಣ, bicarbonate ion. Bicarbonate ion can donate a proton to become carbonate ion. It can as well accept a proton to become carbonic acid. So, bicarbonate ion is a proton donor as well as proton acceptor. Therefore, that is the answer. NH3 is a very common base. It can only accept a proton. Very difficult to take out a proton from NH3. NH3 is also a Bronsted base. ಆದ್ದರಿಂದ ಆನ್ಸರ್ ಯಾವುದು? C. HCO3 minus. Even water is a both Bronsted acid and Bronsted acid. Water can as well accept proton and donate. Yes, question number 46 has appeared in your screen. pH of 10 to the power of minus 3 molar HCl is diluted 1000 times. What will be its pH? So, we have 10 to the power of minus 3 molar HCl. We have diluted it 1000 times. What will be the pH of the diluted solution? You have a look at the option. Usually students, our mindset will be when any solution is diluted, the property will decrease. That is our mindset usually. In fact, it is correct also. When a solution is diluted, concentration decreases. It is a very common sense. Yes, 10 to the power of minus 3 molar HCl diluted 1000 times should decrease its concentration also by 1000 times. It becomes 10 to the power of minus 6 molar. So when any solution is diluted, the concentration of the solution will decrease. If you dilute the solution by 10 times, the solution concentration decreases by 10 times. If you dilute the solution by 1000 times, the concentration also decreases accordingly 1000 times. So the diluted solution will have a concentration of 10 to the power of minus 6 molar HCl. HCl is a monobasic acid. Therefore, concentration of H plus is also 10 to the power of minus 6 molar. If the concentration of H plus is 10 to the power of minus 6, pH will be 6. So the correct answer is pH is 6, option D. Yes, question number 47 has appeared on your screen. Go through the question. C solid plus CO2 gaseous gives 2CO gaseous. Kp equals 63 atmosphere. Equilibrium constant is 63 atmosphere at 1000 Kelvin. At equilibrium, partial pressure of CO is equal to 10 times the partial pressure of CO2. The total pressure of the equilibrium mixture is, the answer is in atmosphere. You take a pause of 20 to 25 seconds and try to answer this question on your own. Then you can look at the way in which I have worked out this problem and verify. Look here, whenever you calculate the partial pressure equilibrium constant for any reversible reaction, you have to write the partial pressure of the product divided by partial pressure of the reactant at equilibrium. Here the product is carbon monoxide, CO. It should be squared because the stoichiochemical coefficient is 2, divided by partial pressure of CO2. You should ignore carbon because it is a solid. That is very important, because the partial pressure of liquid or a solid is so small that it can be neglected. So that should be borne in mind whenever you are writing the partial pressure equilibrium constant, the partial pressure of the product in the numerator, reactant in the denominator, ignore solids and liquids if any. So KSP is, Kp, partial pressure equilibrium constant is given. Kp is given 63, is given in the problem. Then partial pressure of carbon monoxide is given as 10 times the partial pressure of carbon dioxide, the whole square. So in the place of partial pressure of CO, you can substitute 10 times partial pressure of CO2 divided by PCO2. So simplify, you get PCO2 into 10 square will be 100. Therefore, P of CO2 is 63 by 100, or it is 0.63 atmosphere. P of CO2 is 0.63 atmosphere, option C. So, such problems you better say refer to one or two textbooks and do similar problems on the calculation of Kp. Question number 48 has appeared on your screen. Yes, read that carefully. Alpha glucose reversible, beta glucose, Kc equals 1.8. What is the percentage of alpha glucose at equilibrium? Different answers are given: 35.8, 64.3, 55.6, 44.4. All these are percentages. Equilibrium constant is given. You are supposed to Find the percentage of alpha glucose at equilibrium. Yes, you can take a pause of 10 to 20 seconds on this video and work out on your own. Afterwards, better you see how I have worked with this problem and verify. This is a common instruction for all the questions. Yes. Kc is molar concentration equilibrium constant. Yes, it is the molar concentration of the product divided by molar concentration of the reactant. Yes, it is molar concentration of beta glucose divided by molar concentration of alpha glucose. It is given as 1.8. You can take this as 1. So what do you infer from this? Beta glucose and alpha glucose are in the ratio of 1.8:1 at equilibrium. That means if you take concentration of beta glucose as 1.8, you must take alpha glucose as 1. So, beta glucose and alpha glucose are in the ratio of 1.8:1 at equilibrium. So, total concentration is 2.8. Out of 2.8, alpha glucose is 1. 1 out of 2.8. Percentage means into 100. Yes, this can be easily simplified. This is 1000 over 28. Taking 28 approximately as 25, this will be 40. So the answer is close to 40 but less than that, because I have approximated 28 as 25. The answer is close to 40 but less than 40. So obviously it is A, 35.8. In fact, you have to resort to such methods of simplification to save time in the competitive exam. So that's an easy question but slightly brain twisting. Percentage is asked, equilibrium constant. Here you must think that beta glucose and alpha glucose are in the ratio of 1.8:1 at equilibrium.
As an educational institution, do you face any of these problems? Looking to increase admissions? Difficulty finding good teachers? Facing an issue managing vendors? All that is about to change. EdCart is here to help. EdCart is India's one-stop platform for all your education-related product and services. EdCart helps you in generating online inquiries by profiling your school page. Parents can inquire or apply for admissions for your school online. Not just that, it helps you in hiring your faculty. Find the right talent at the right time. EdCart is an online portal where parents can shop for school books, uniforms, shoes and bags from verified vendors. We ensure quality, best price and on-time delivery. EdCart offers other services like school fee EMI option, school ERP, a mobile app for effective communication between parents and teachers, and counseling services for students. Partner with us right away. Sign up for free at www.edcart.com. Call us on 8088468846 or drop in an email at support@edcart.com.
Yes, students, question number 49. Go through the question carefully. A little long, a lengthy question. N2 plus O2 reversible 2NO equilibrium constant K1. 2NO plus O2 reversible 2NO2 equilibrium constant K2. NO2 reversible half N2 plus O2 equilibrium constant K. You have been asked to find the relationship between K, K1 and K2. Such problems are commonly asked, so you must attentively follow this problem and work out similar problems from the textbook you have. Look, in solving such problems, you must first look at the required equation. NO2 reversible half N2 plus O2. This equation we must get. Look at the first equation. We have NO2 on the right side. We want NO2 on the reactant side. So reverse this equation. If you reverse the equation, the rule says the equilibrium constant becomes its reciprocal. If you reverse, you get NO2 no doubt on the left side, but you get 2 NO2, we want 1 NO2. To get 1 NO2, you have to multiply this equation throughout by half. So 2 operations must be done on that equation. One, reversing the equation, multiplying the equation throughout by half. When the equation is reversed, the equilibrium constant becomes its reciprocal. If you multiply the equation by a factor x, the equilibrium constant gets rise to x. Look here, if you reverse that equation, you get NO2 reversible, NO2 reversible, NO plus half O2. To get this equation, you have, what have you done? You have reversed the equation, therefore the equilibrium constant becomes 1 over K2, and you have multiplied the equation throughout by half, therefore the equilibrium constant becomes 1 over K2 to the power of half. Yes, follow this rule carefully. You have reversed the equation, therefore the equilibrium constant becomes its reciprocal. After reversing, you have multiplied the equation throughout by half, the equilibrium constant gets rise to the power of half. Yes, we have to get this equation. We don't need NO here. To do that, we shall take the help of the first equation. Look, we want NO on the right side itself, because we want to eliminate NO by subtracting. Look, same thing we shall do for the equation 1 also. We shall not reverse, we shall multiply the equation throughout by half. Then what happens? Reverse the equation and multiply by half. NO reversible half N2 plus half O2. Same thing you have done for the equation also. Its equilibrium constant becomes reciprocal and gets rise to the power of half. Why? We have reversed the equation 1, therefore it becomes 1 by K1. Rise to the power of half because we have multiplied the equation throughout by half. Now what you do is add these two equations. NO cancels with NO. NO2 reversible half N2, half O2 plus half O2 is 1 O2. You got the required equation. When you add any two reversible equations, again the rule number 3, their equilibrium constants gets multiplied. That is the rule. So the equilibrium constant becomes 1 by K2 to the power of half into 1 by K1 to the power of half will be 1 by K1 K2 to the power of half. So the equilibrium constant of this equation will be 1 by K1 by K2 raised to the power of half, option C. 3 rules you have to remember. Number 1, when you reverse the reversible equation, the equilibrium constant becomes its reciprocal. Second, if you multiply the reversible equation by any number, say x, equilibrium constant gets rise to the power of x. When you add two reversible equations, their equilibrium constants gets multiplied. So if you know these three rules, you can work such problems. I hope you have followed this. We shall pass on to the next question, question number 50. Question number 50 has appeared on the screen. We can go through that question and think on your own. Try to solve as much as possible on your own. At 60 degrees Celsius and 1 atmosphere pressure, N2O4 is 50% dissociated into NO2. What is its partial pressure equilibrium constant expressed in atmospheres? That is a problem. N2O4 is 50% dissociated. N2O4 is dissociated. First write this equation. Both are gases. Okay. Yes. At 60 degrees Celsius and 1 atmosphere pressure. Now, 50% dissociated means, suppose you have taken 1 mole of N2O4, half of it means 0.5 mole of N2O4 has dissociated and another 0.5 is left undissociated. 50% of 1.5. Out of 1.5 has dissociated, 0.5 has remained undissociated. Look at the equation. If 1 N2O4 dissociates, you get 2 NO. NO2 obtained is twice of N2O4 dissociated. So if 0.5 dissociated, twice of it means 1 mole NO2 we get. So at equilibrium you have 0.5 mole of N2O4 and 1 mole of NO2. This one at equilibrium only 0.5 mole of N2O4 is left and we have 1 mole of NO2. Total number of moles is 1.5. 1 plus 0.5. Partial pressure of NO2. Recollect the formula, how to calculate partial pressure. Partial, if you have forgotten, write the formula. Partial pressure of a gas equals mole fraction into total pressure. I'll repeat. Partial pressure of a gas is equal to mole fraction into total pressure. Mole fraction means the number of moles of this gas, how much? 1, divided by total number of moles. This is called mole fraction. Into total pressure is given as 1 atmosphere in the problem. So it will be 1 over 1.5 or 2 by 3 atmosphere. P of N2O4 similarly, number of moles of N2O4 left is 0.5 divided by 1.5, this is called mole fraction, into total pressure given in the problem is 1 atmosphere. So it will be 0.5 by 1.5 or it will be 1 by 3 atmospheres. PNO2 is 2 by 3, PN2O4 is 1 by 3. Yes, let us write an expression for Kp now. Product over reactant. Product NO2. The square, why? Stoichiometric coefficient is 2. Divided by P of N2O4. Substitute. P of NO2 is 2 by 3. 2 by 3 the whole square is 4 by 9. P of N2O4 1 by 3. Cancel these two. You get 4 by 3 is 1.33 atmosphere. So the partial pressure equilibrium constant is 1.33 atmosphere, option A. By solving this problem, you have got some important formulae. You must calculate how much product is formed, how much reactant has remained at equilibrium. Then you can calculate total number of moles Once you know the total number of moles, you can calculate partial fraction, mole fraction. Mole fraction multiplied by total pressure gives you the partial pressure. Such problems are repeatedly asked. You should give a little more attention for problems of the same time. Students, we shall stop this session now. The rest of the questions, definitely I will try to answer in the coming class. Thank you very much.